NEC 800.47, addressing general requirements for telecommunications cabling, does not explicitly address the need for encasement of conduits used for telephone service. However, it states that telecommunications cabling shall be installed in accordance with NEC Article 300, which covers wiring methods. NEC 300.6c requires that conduits in exposed locations be enclosed in a protective covering unless the wiring method is self-protected. This requirement applies to electrical conduits, but it does not explicitly mention telecommunication conduits. Based on the available information, it is unclear whether exposed conduits for telephone service on the first floor require encasement. While NEC 800.47 does not specifically address this, NEC 300.6c requires encasement for exposed conduits unless the wiring method is self-protected. To ensure compliance and protect the conduits from damage, it is recommended to consult with local authorities and follow their interpretations of the NEC. You may also consider using conduits that are self-protected, for example, non-metallic conduits, or enclosing the exposed conduits in a protective covering. Let's delve into the details of these NEC sections and provide a more comprehensive understanding of conduit encasement requirements. Firstly, NEC 800.47 provides general guidelines for telecommunications cabling, emphasizing adherence to NEC Article 300 for wiring methods. This means that while 800.47 doesn't explicitly mandate encasement, it directs us to Article 300, which might contain relevant requirements. Secondly, NEC 300.6c is a critical section to examine. It stipulates that conduits in exposed locations must be enclosed in a protective covering unless the wiring method is self-protected. The key question here is whether this requirement applies to telecommunication conduits, as it specifically mentions electrical conduits. The ambiguity arises because the NEC doesn't provide a clear distinction between electrical and telecommunication conduits in this particular context. Therefore, we need to consider the intent and purpose of the encasement requirement. The primary reason for encasing exposed conduits is to protect them from physical damage. This protection can be achieved through various means, including using rigid metal conduit, intermediate metal conduit, or rigid non-metallic conduit encased in concrete. Encasement prevents damage from impacts, abrasion, and other environmental factors. Given that telecommunication conduits are also susceptible to physical damage, it's reasonable to argue that the encasement requirement should apply to them as well. However, the NEC lack of explicit language on this matter leaves room for interpretation. This is where consulting with local authorities becomes crucial. Local electrical inspectors and code officials can provide valuable insights into how the NEC is interpreted and enforced in a specific jurisdiction. The guidance can help ensure compliance with local regulations and prevent potential issues during inspections. In addition to consulting local authorities, exploring alternative solutions can be beneficial. One option is to use self-protected conduits. These are conduits designed to withstand physical damage without additional encasement. Examples include rigid non-metallic conduits made from high-impact resistant materials. Another approach is to provide a separate protective covering for the exposed conduits. This could involve installing a metal or plastic channel over the conduits or encasing them in a concrete pad. The choice of protective covering depends on the specific environment and the level of protection required. In summary, while the NEC doesn't explicitly require encasement for telecommunication conduits in all situations, it's prudent to take a conservative approach and provide adequate protection. Consulting with local authorities, using self-protected conduits, or installing a protective covering can help ensure compliance and safeguard the telecommunication infrastructure. Now, let's consider specific scenarios and how the NEC might apply. Imagine a situation where the telecommunication conduit runs along an exterior wall of a building. In this case, the conduit is exposed to weather conditions, potential impacts from vehicles, and other hazards. Encasement or a protective covering would be highly recommended to prevent damage and maintain the integrity of the telecommunication system. Alternatively, suppose the conduit is located in a relatively protected area, such as inside a mechanical room or above a suspended ceiling. In such cases, the risk of physical damage might be lower, and the need for encasement might be less critical. However, it's still essential to assess the potential risks and ensure that the conduit is adequately protected. Another factor to consider is the type of telecommunication cabling installed within the conduit. If the cabling is sensitive or critical, such as fiber optic cables, providing additional protection would be advisable. Fiber optic cables are more susceptible to damage than traditional copper cables, so encasement or a protective covering can help prevent costly repairs and downtime. When selecting a conduit material, several options are available. Rigid metal conduit provides excellent physical protection, but can be more expensive and difficult to install. Intermediate metal conduit offers a balance between protection and cost. Rigid non-metallic conduit is lightweight, corrosion-resistant, and relatively easy to install, but it might not provide the same level of physical protection as metal conduits. The choice of conduit material depends on the specific application and the level of protection required. In addition to encasement, proper grounding and bonding of telecommunication conduits are essential for safety. Grounding and bonding help prevent electrical shock hazards and ensure that the telecommunication system operates reliably. The NEC provides detailed requirements for grounding and bonding in Article 800 and Article 250. It's crucial to follow these requirements to ensure a safe and compliant installation. Let's delve into some additional considerations for telecommunication conduit installations. Firstly, consider the routing of the conduit. Whenever possible, avoid running conduits through areas where they are likely to be exposed to physical damage. If it's necessary to run conduits in such areas, provide additional protection, such as encasement or a protective barrier. Secondly, pay attention to the supports for the conduit. Conduits must be properly supported to prevent sagging or displacement. The NEC specifies the maximum spacing between conduit supports in Article 344 for rigid metal conduit, Article 352 for rigid non-metallic conduit, and other relevant articles for different types of conduit. Thirdly, ensure that the conduit fittings are properly installed and tightened. Loose or improperly installed fittings can create weak points in the conduit system, making it more susceptible to damage. Use appropriate tools and techniques to tighten the fittings to the manufacturer's specifications. Fourthly, consider the potential for corrosion. If the conduit is installed in a corrosive environment, such as near a chemical plant or in a coastal area, use corrosion-resistant materials such as PVC-coated conduit or stainless steel conduit. These materials can help prevent corrosion and extend the life of the conduit system. Fifthly, be mindful of the fill capacity of the conduit. The NEC limits the number of conductors that can be installed in a conduit to prevent overheating and ensure proper ventilation. Refer to NEC Chapter 9, Table 1 for conduit fill requirements. Finally, document the conduit installation. Keep records of the conduit routing, materials used, and any special considerations. This documentation can be helpful for future maintenance and troubleshooting. By following these guidelines and consulting with local authorities, you can ensure that telecommunication conduit installations are safe, compliant, and reliable. Remember that the NEC is a complex document, and it's always best to seek professional guidance when in doubt. Now, let's explore some specific examples of how these principles might be applied in real-world scenarios. Imagine a new office building is being constructed. The telecommunication room is located on the second floor, and the telephone service enters the building on the first floor. The conduit for the telephone service will be exposed on the first floor. In this scenario, several factors need to be considered. Firstly, the location of the conduit is exposed, meaning it's susceptible to physical damage. Secondly, the type of cabling being used is telephone service, which might be sensitive to damage. Thirdly, the local authority's interpretation of the NEC is unknown. Given these factors, a conservative approach would be to encase the exposed conduit in concrete or use a self-protected conduit, such as rigid non-metallic conduit. This would provide adequate protection and ensure compliance with the NEC. Alternatively, consider a situation where an existing building is being renovated. The telecommunication conduit is already installed and running through a protected area, such as above a suspended ceiling. In this case, the need for additional encasement might be less critical. However, it's still essential to inspect the conduit for any signs of damage and ensure that it's properly supported and grounded. If the conduit is in good condition and the risk of physical damage is low, it might be acceptable to leave it as is. However, if there are any concerns, it's always best to err on the side of caution and provide additional protection. Let's now talk about the importance of coordination with other trades. Telecommunication conduit installations often involve coordinating with other trades such as electrical contractors, mechanical contractors, and general contractors. Effective communication and coordination are essential to ensure that the conduit is installed properly and doesn't interfere with other building systems. For example, the telecommunication conduit should be installed in a way that doesn't block access to electrical panels or interfere with the operation of mechanical equipment. Similarly, the conduit should be routed to avoid conflicts with plumbing pipes or HVAC ducts. By coordinating with other trades, you can prevent potential problems and ensure a smooth and efficient installation. In conclusion, telecommunication conduit encasement requirements are not always straightforward. The NEC provides general guidelines, but the specific requirements can vary depending on the situation and the local authority's interpretation. By consulting with local authorities, using self-protected conduits, providing a protective covering, and coordinating with other trades, you can ensure that telecommunication conduit installations are safe, compliant, and reliable. The key is to take a risk-based approach and assess the potential hazards in each situation. If there is a significant risk of physical damage, providing additional protection is always a good idea. Remember that the goal is to protect the telecommunication infrastructure and ensure that it operates reliably for years to come. Always refer to the latest edition of the NEC and consult with qualified professionals when in doubt. Now let's consider some advancements in conduit technology and their impact on encasement requirements. Firstly, the development of high-strength, impact-resistant non-metallic conduits has reduced the need for traditional encasement methods. These conduits can withstand significant physical abuse without cracking or breaking, making them suitable for exposed locations. Secondly, the introduction of flexible metal conduits and liquid-tight flexible metal conduits has simplified the installation process and reduced the need for rigid conduit systems. These flexible conduits can be easily routed around obstacles and can be used in tight spaces where rigid conduits would be difficult to install. Thirdly, the use of prefabricated conduit assemblies has streamlined the installation process and reduced the amount of labor required. These assemblies are manufactured off-site and delivered to the job site ready to be installed, saving time and money. Fourthly, the development of new grounding and bonding techniques has improved the safety and reliability of telecommunication conduit systems. These techniques include the use of grounding bushings, bonding jumpers, and other specialized hardware. Finally, the integration of smart technology into conduit systems has enabled remote monitoring and control. These smart conduits can detect potential problems, such as water leaks or corrosion, and alert maintenance personnel. By leveraging these advancements in conduit technology, you can improve the performance, reliability, and safety of telecommunication conduit installations. However, it's essential to stay up to date on the latest codes and standards and consult with qualified professionals to ensure that the technology is used properly. Let's dive deeper into the specific types of conduits that are commonly used in telecommunication installations. Firstly, rigid metal conduit, often referred to as RMC, is a heavy-duty conduit made of steel or aluminum. It provides excellent physical protection and is suitable for exposed locations where there is a high risk of damage. RMC is typically used in industrial settings, commercial buildings, and outdoor applications. Secondly, intermediate metal conduit, or IMC, is a lighter weight version of RMC. It provides similar physical protection but is easier to bend and install. IMC is often used in commercial buildings and light industrial applications. Thirdly, electrical metallic tubing, or EMT, is a thin-walled conduit made of steel or aluminum. It's lightweight and easy to bend, making it suitable for concealed locations where there is a low risk of damage. EMT is commonly used in residential and commercial buildings. Fourthly, rigid non-metallic conduit, often called PVC conduit, is a lightweight, corrosion-resistant conduit made of polyvinyl chloride. It's suitable for both indoor and outdoor applications and is often used in corrosive environments. PVC conduit is easy to cut and install, but doesn't provide the same level of physical protection as metal conduits. Fifthly, flexible metal conduit, or FMC, is a flexible conduit made of steel or aluminum. It's used to connect equipment that vibrates or moves and is often used in tight spaces where rigid conduits would be difficult to install. Sixthly, liquid-type flexible metal conduit, or LFMC, is a flexible conduit that is coated with a liquid-type plastic jacket. It's used in wet locations or where there is a risk of exposure to oil or chemicals. The choice of conduit type depends on the specific application, the level of protection required, and the environmental conditions. It's essential to select a conduit that is suitable for the intended use and to install it according to the manufacturer's instructions and the NEC requirements. Let's now consider the economic aspects of telecommunication conduit installations. The cost of conduit installations can vary significantly depending on the type of conduit used, the complexity of the installation, and the labor costs. Rigid metal conduit is typically the most expensive, followed by intermediate metal conduit, electrical metallic tubing, and rigid non-metallic conduit. Flexible metal conduit and liquid-type flexible metal conduit are generally less expensive than rigid conduits. Labor costs can also vary depending on the location and the skill level of the installers. It's essential to obtain competitive bids from qualified contractors and to carefully evaluate the costs before making a decision. In addition to the initial installation costs, it's also important to consider the long-term costs of maintenance and repairs. Rigid metal conduit and intermediate metal conduit are generally more durable and require less maintenance than electrical metallic tubing or rigid non-metallic conduit. However, if a conduit is damaged, it can be expensive to repair or replace. By carefully considering the economic aspects of telecommunication conduit installations, you can make informed decisions that will save you money in the long run. It's important to balance the initial costs with the long-term costs of maintenance and repairs. And finally, let's talk about the importance of ongoing training and education. The NEC is constantly evolving, and it's essential to stay up to date on the latest codes and standards. There are many resources available for ongoing training and education, including seminars, workshops, online courses, and industry publications. It's also important to participate in professional organizations and network with other professionals in the field. By investing in ongoing training and education, you can improve your skills and knowledge and ensure that you are providing the best possible service to your clients. The telecommunications industry is constantly changing, and it's essential to stay ahead of the curve. This includes understanding the latest technologies, the latest codes and standards, and the latest best practices.